Guys, welcome back to TechDose, and in this video we will look at snakes and ladders problem, which is from Leetcode number 909. Let's now look at the problem statement. In this problem you are given an n by n integer matrix board where the cells are numbered from 1 to n square in a Flattening style, starting from the bottom left of the board and alternating direction each row. So in a normal style you will be always writing from left to right. So whenever you number them you can write 1, 2, 3, 4, 5, 6, 7, 8 and so on. But in a Flattening style you will be spiraling. So if you write 1, 2, 3, 4, then the next row will be alternating. So it will be 5, 6, 7, 8 and then 9, 10, 11, 12 and so on, right? So it will be spiraling. This is the Flattening style. You can start on square 1 of the board. In each move starting from the square current, do the following. Choose a destination square next with the label ranging from current plus 1 to minimum of current plus 6, n square, so that you don't go out of range of the board. And this choice simulates the result of the standard 6-sided die roll. There are always at most 6 destinations regardless of the size of the board. Now let me show you what they are trying to say. So you are starting at this number 1, which is the first cell, and from here you can make 6 possible choices. You can either go to the next cell or to the second cell, third cell, fourth cell or fifth cell, and you have another option 6th cell. So equivalent to the value that you can get in a die roll, the value can be from 1 to 6. You can make these possible choices in the next hop, right? In the next move you can start with 1 and say that my number of moves are 0, and in the first move you can go to any one of these cells from 2 to 7. Now it is also mentioning that you cannot make any random size jump, because let's say if you were at 33, then from here you can make 1 size, 2 size and only 3 size jump, but you cannot make a 4th size jump because you will go outside of the board. So that is why from whatever place you are making the jump, you have to consider that you are taking minimum of the current index plus 6, n square, so that you don't go outside of the board. Okay. Now if next has a snake or ladder, you must move to the destination of that snake or ladder, otherwise you move to the next. So this means that if the next choice, from wherever you make the choice, if you have a snake or ladder, like if you have a ladder just in the next choice, you can take that ladder and only one time. You cannot take it multiple times. So if you again had a ladder from 15 to 33, well, you cannot take it. Okay, if you had taken the ladder from 2 to 15, you cannot take from 15 to 33 again. You have to stop here. You have to stop here and you have to only move forward. So you cannot take multiple ladders at the same time. Even if you had a snake, you didn't had a ladder here, but you had a snake here, which is bringing you down to 3. Then if you had climbed from 2 to 15, you cannot take the snake from 15 again to 3. That is not possible. Okay. The game ends when you reach to the last cell. So in this case, the cells are always starting at the bottom left corner, right? If you look here, it is starting in this way. So the last cell may not always be on the top left. It can also be on the top right. Like if I number a 3 by 3 cell, then you will see the 3 by 3 matrix will be 1, 2, 3, 4, 5, 6 and 7, 8, 9. So in this case, the last cell is the top right corner. And if you make this kind of example, then in this case you saw in a 6 by 6 matrix, you are getting it at the top left corner, right? So depending on whether you have taken odd value as n value, that means in this case n value is 3, so this is a 3 by 3 matrix, so the last cell is on the top right corner. If it was even size, that means in this case 6 by 6 matrix where 6 is even, then you will find it in the top left corner, right? Because of the Flattening style. Okay. A board square on row R and column C has a snake or ladder. If board at RC is not equals to -1, the destination of that snake or ladder is board at RC. Squares 1 and n square are not the starting point of any snake or ladder. So if you check out again the input values, then in this case, this board are given row wise. So this is the top row. This is row number 0. This is row number 1. This is row number 2, row number 3, row number 4 and row number 5. So this is arranged in the top down order. And wherever you see -1, this means you don't have any ladder or any kind of snake starting there. Okay, it can end there, but it is not starting. But wherever you find a number, let's say that in the fourth row and the second column, 1 2 3 4, fourth row and the second column, you are seeing a number 35. This means if you reach to this cell, you will get to 35. Now if this number is smaller number and you are reaching to a higher number, then that is considered as a ladder. But if this number was not 35 but it was written somewhere like 3, then this will become a snake. So there is no distinction between snake or ladder. It is just like when you reach to a cell, you will get a destination cell to reach, and if you go up on a higher number, then that is a ladder. Otherwise, if you go to a lower number, it is a snake. Otherwise, there is no other distinction present. Okay, if you look at this 13, then at this 17 number cell, if you go, then it will take you to 13, which is decreasing your number, and that is why it is a snake, right? So that is how the input arrangements are given. Now if you see the next part of the question, note that you only take a snake or ladder at most once per dice roll. If the destination to a snake or ladder is the start of another snake or ladder, you do not follow the subsequent snake or ladder. This I have already explained, right? For example, suppose the board is -1 4 -1 3. Then in this case, on the first move, your destination square is, let's say, 2. So you are reaching to this 3. Then from this 3, if you are reaching here, because if you number them, it will be 1 2 3 4, right? So if you reach to this 2, because you are starting always at 1, and if you reach to this 2, then it is saying that go to 3. So if you go to 3, the 3 is saying that go to 4. So you cannot take multiple ladders. Here there are 2 ladders. Okay, one is taking you up and another one is fast forwarding you in on the same row on the left hand side. So just by making one move from 1 to 2, you are reaching to the destination, and this kind of nested movement is not allowed. Okay, so that is what the example is saying. You follow the ladder to square 3, but do not follow the subsequent ladder to 4. If you take a ladder or a snake, you can just do it one time in that particular move, and the next time you have to take a step from size 1 to size 6 maximum. Okay, I think you have understood how the input is given. We need to return the least number of dice rolls required to reach the square n square, and if it is not possible to reach, then you return -1. Well, in this particular example, when this will not be possible to reach, let's assume that this ladder itself is not present, and these values are taking you to some kind of smaller cells. That means these are all snakes. Okay, they are taking you to smaller cells. You see how I am drawing this? They are all taking you to smaller cells. Now for this particular case, the highest value that you can reach is 27, because as soon as you reach to 27, from here if you make a 1 size jump, you go to 4. You make a 2 size jump, you go to 5. 3 size jump, you go to 6. 4 size jump, you go to 7. 5 size jump, you go to 8. And 6 size jump, you go to 9. Fine. So if this ladder is not present, then this snake configuration will never allow you to pass through 33, and you will never be able to reach to 36. So this kind of arrangement with consecutive snakes will return -1 value, because you will never be able to reach to the last cell. Okay, so I think everything is clear. If you look at the constraint, then the n value is pretty small, that is 20. So the board size will be 20 by 20. That means 400, or you can say 4 times 10 to the power 2. So if you happen to write an n square algorithm, that will be 16 times of 10 to the power of 4, which will be 1.6 times of 10 to the power of 5. So this is well within your 10 to the power 8 range. So definitely an n square algorithm will be optimal. N is the number of rows and the number of columns as well. Boards at ij is either -1, indicating that it is not a starting point of a snake or ladder, or it will be in the range of 1 to n square. If it is a ladder, where it is taking you to, and if it is a snake, then where it will take you to. The squares labeled 1 and n square are not the starting point of any of the snake or ladder. That means the first cell where you are starting and the destination can never have any kind of snake or ladder. Okay, so having understood this, let's try to understand the flattening technique, because we will be using this to solve the problem. So how to flatten a 2D matrix into a 1D matrix? How to imagine that? Now in this case, in general, if you are given a matrix, in this case I have taken 4 by 4 matrix. Okay. If I number all the cells in the usual order, that means this is not the Bostrophian order. This is just a simple order left to right for all the rows. Then if I give you a row and column number r comma c, then you can always flatten it into a 1D index r times n plus c, where it is an n by n matrix, right? That you can always do. So in this case, if I take an example of 1 comma 3, that means I'm trying to get the index of this in the 1D. So I have written all the numbers which are the indices in the 1D, because the first row from 0 to 3 will be here, and then from 4 to 7 will be just appended, right? And that is why the numbers are made 0, 1, 2, 3, 4, 5, 6, 7 and so on. So for index 1, 3, what is its equivalent index in the 1D array? It will be the row number 1 is indicating how many rows you have skipped. So in each row, the total number of columns will be taken, right? So if you have skipped one row, then 1 times 4, because 4 columns are there per row. So 1 times 4 plus the column number that you are present in is 3. So that means you must have skipped 3 columns on the left, because counting starts from 0. So plus 3. So this is giving me index 7, which is correct, right? So if the 1D index is, let's say, index, which is IDX, then the row can be calculated by index by n. Row can be calculated by index by n, and the column can be calculated by index mod of n. If you take an example, if I take index 11 in 1D, what is its equivalent row comma column value in the matrix? It should be 2 comma 3, right? So how we can calculate it? The row will be 11 by n value, which is 11 by 4, which is 2, and the column will be 11 mod of 4, which is 3. So it is saying 2 comma 3. This is how you convert 2D indexing to 1D and 1D to 2D. This is the general idea. We will use this same technique in our case, but in our example, it is not given on left to right, and it is not given in the top down order. If you look at the example, then it is given in the bottom up order, and also at every odd level it is written in a reverse order, right? This is the Bostrophian style, right? So if you have to calculate in such case, let's try to calculate for cell number 5. What will be the row comma column? So if you take this 5, then in general case, if you are taking a 4 by 4 matrix, then doing 5 by 4 will give you a value 1. Okay. So if you do 5 by 4, it should give you a value 1. Now in this case, the counting is starting with 1. Previously, the counting was starting with 0, because in our example, the counting is always starting with 1. That is why I will be taking from 1. So we need to adjust the offset by doing -1, so that all the numbers here matches up with our previous matrix. So I will be taking whatever index you are giving, because index, I will assume that it is starting with 0. Okay. I am assuming that it is starting with 1 here, but actually in reality it should start with 0. So 5 minus 1 will be 4. So this cell here should have been 4, as you see here, right? 4 by 4 will give you 1. That means it is row number 1. Row number 1. And if you see the column number, 5 minus 1 mod of 4, 0. So row number 1 and column number 0, which is the correct position for 4. But if you look here, if you had just stopped here at 1 comma 0, then it is giving you 9. It is not giving you the actual value 5. Why this is happening? Because in the previous case, we were calculating the rows moving top down. But in this case, we are actually calculating it in the opposite order. Okay, even though the numbers are mentioned 0, 1, 2, 3 top down, but the actual intended value I want to get is this 5 according to the input, right? So that is why I have to actually change up my row number as well as the column number. Okay, so if I have counted 2 times down, that means 1 means I am going to the second row from top. Then if you just mirror it, okay, mirror it means if you move from the bottom the same number of moves, then you would have reached to 2. And if this is a odd number row, then that means you must have been writing from the reverse order. That means right to left. If you are writing from left to right, the column number will not change. But if you are writing from right to left, then whatever is the index here 0, this has to be mirrored as well. So you need to get the mirror of 0 from the middle. That means you have to go to index number 3. How to get all these things? You first find the top row. How to find the top row? Get the value, offset it with -1, so that I will be assuming that the value starts with 0, index starts with 0. So 5 minus 1 by 4 is 1. That means row number 1. But if you count from the bottom, the actual row number will be n minus top row minus 1. You see here, the top row will be, if you have index I, then it is index I minus 1 by n. And so when you count from the bottom, it will be n minus top row minus 1. Similarly, for the column, you can simply calculate the column by doing the offset 5 minus 1 mod of 4, which is 0, 0th number column. But this will be adjusted provided if you are seeing a odd row or an even row. If you are seeing an odd row, then you must have written in the reverse order. So that means the index have to be adjusted, right? So if you adjust the index, then it will be, if a row is odd row, then you have to do column equals n minus column minus 1. That means n value is 4 here. So 4 minus 0 minus 1 will be 3. So that means I will be getting column number 3 and row number 2, which is correct, 2 comma 3, right? That is what was my intended value. So this is the actual conversion that we are using. But the idea comes from our general case, that starting from 0 and going in our usual order. But I just converted it in to match our requirements. Okay, so this conversions I will not be showing you in the dry run. I hope you have understood this. You can rewatch again and you will definitely understand. So this flattening technique I will be using because I will assume the entire matrix to behave like a 1D array. Okay, once you know this, then the problem is asking about reaching from a source node, which is this 1 to the destination node, which is 16 in our case, because it is a 4x4 matrix. So we need to reach from source to destination with minimum number of steps. So you can assume that each step has the same cost, because if you take a hop, means it is cost 1, it is cost 1 whenever you take the hop. So when all the hops have the same cost, then you can simply go with the BFS technique. It is the shortest path algorithm. If different hops would have different cost, okay, it would incur different cost, then in that case you cannot just do it by BFS, but it is very highly likely that you have to take a priority queue with on top of it, which is a heap. And that technique with BFS plus heap will become the Dijkstra shortest path algorithm, single source shortest path, right? But in this case, we don't need to use Dijkstra. We just need a simple BFS. Even if you apply Dijkstra, it will pass, but we will be just going with a simple BFS. How to apply BFS? We know the starting point is 1. Okay. I will be taking a queue and I need to count in how many hops I am reaching to 16 if possible. Otherwise, if not possible, return -1. Now, if it is not possible to reach from source to destination, you should not fall into an infinite loop. It is possible that you fall into an infinite loop going up the ladder, climbing down, again going up and climbing down, right? So if such kind of scenario can happen, which will happen definitely, then you need to maintain that whenever you reach to a cell, you cannot visit it again. And for that reason, I will be taking a visited 2-dimensional array, which I will not be showing you in the dry run. But whenever I go to a node and I push it into the queue, then the visited at that row comma column will be made as true, so that the next time that same node is not getting processed. That means the same cell do not get processed, right? So this will incur a space complexity of O(n) square, definitely, right? So that is the extra space I will be taking. Now let's start with 1. So I will be simply doing the dry run, and I have written all the numbers. Actually, all these numbers will be written with -1 as given in the input, right? And if there is a ladder starting somewhere, then the actual cell number will be written where it takes to. And if there is a snake starting somewhere, the actual cell number will be written where it takes to. So I have already written them in white color. Otherwise, I have written the exact cell number. You can assume the cell numbers are actually represented by -1. So this will make the dry run easy to understand. Now let's start our traversal from the source node. So I'll be finding how many items are there at the first level, finding the size of the queue, and then take out this item 1. once you take it out, you have to check if it is equals to the destination node where we want to reach. So 1 is not equals to 16, right? So we will take it out, and then I will be checking what all options are there so I can reach to 2. Okay, so this 1 would have been marked as visited when it was inserted. Then if you want to go to 2, you have to check if it is visited, not visited, then mark it visited and insert into the queue. Again, 3 is not visited, mark it visited and insert into the queue. Similarly, 4, 5, 6 and 7, all of them will be marked as visited and will be inserted into the queue. Because you can take 1 size jump to 2, 2 size jump to 3, 3 size jump to 4, 4 size jump to 5, 5 size jump to 6 and 6 size jump to 7. And that is how these are all inserted. Now the first level is done, level 0 is done. When you go to the next level, increase the level counter to 1 and then find the size of the queue. These all will be at level 1. So the size of the queue is 6. Now we need to process each of them one by one. So when you take out this 2, you have to check if 2 is equals to the final node 16. No, it is not equal. So what we have to do, we have to see what all options I have. So from 2 I can go to 3, but 3 is already visited, 4 already visited, 5 already visited, 6 already visited, 7 already visited, but I can go to 8. I can go to 8. Okay, so from 2 I will go to 8, and since 8 has a ladder, I can process one ladder or one snake exactly one time. So I will not be marking it as visited, but rather I will take the ladder and I will be reaching to 14. Fine. When I take the ladder, then immediately I will mark it as visited 14 and I will be inserting it into the queue saying 14 is now visited. Okay, so these are all the 6 jumps that I could have taken, and you are done with this 2. Now you take out the 3 and check out. From 3, 4, 5, 6, 7 cannot be taken. If you take this 8, then you will reach to 14, which is already visited, so no need to take it, and you can reach to 9. Okay, so this is like from 3, 1, 2, 3, 4, 5, 6. So 6 steps will make you reach to 9. Insert a 9 here, mark it as visited. Right? Similarly, take out 4. For 4, you will explore that 10 is the new node and 10 will get inserted. All the previous nodes have been visited. For this 5, again when you take it out, then 11 will be the one where you get visited. So 11 will be inserted. When you take out this 6, okay, when you take out this 6, then you will see that this is the new node where you can mark it as visited. So I will not be marking it because this is behaving like a ladder. When you reach to 12, it is taking you to 2. Now since 2 is visited, so you will not be inserting it. Okay, you are done with 6. When you go to 7, again all the same nodes will be seen, 8, 9, 10, 11, 12. But a new node 13 will be seen, and so 13 will be inserted and mark it as visited. You are done with level 1. Fine. Now let's go to the next level. So when you go to the next level, again you need to find the size of the queue, which is 1, 2, 3, 4, 5. Increase the level counter to 2. And now you have to start your BFS from 14. So when you start your BFS from 14, then you check is 14 equals to where I wanted to go. No, I wanted to go to 16. So it is not. You take it out and then you see how many hops can you take. So it will not be just 1 to 6 hops, but it should also be checked that you should not go out of bound. So you can only take 2 size hops, 1 or 2. Okay. So if you take 1 size hop, you will reach to 15, mark it as visited and insert it into the queue. Right. Then you can take 2 size hop to 16, mark it as visited and insert it in the queue. And that's all. If you start from 9, then you cannot cover anything. 10, 11, if you go to 12, then it will take you to 2 again, and which is visited. So we will not take it. 13, 14, 15 and so on, right? Now for this 10 as well, you will not be seeing any new node. You can check it out. And for 11, 13, you will not be seeing any new node. Okay, you cannot push 16 multiple times because it is visited one time. So you are done with level 2. Go to the next level. Find out the size. Take out 15. From 15, check out how many jumps you can make. You can only make 1 jump, but this is already visited, so it will not be inserted. You take out 16, and this is the destination node, and that is where your BFS will stop, and whatever is the level count will be the shortest path. The shortest path is 3. That means 3 is the minimum number of hops that you take in order to reach to the destination node. So if you check it out, then you can go from 1 to let's say 6, from 6 to 8 and 8 you climb to 14. So going from 1 to 6 is one hop, going from 6 to 14 is the second hop, and going from 14 to 16 is the third hop. This is one combination. You can go to 1 to 5, 5 to 14, and 14 to 16 as well. So there can be multiple paths, but 3 is the minimum number of hops, and therefore the answer is 3. So I hope it is clear. In this case, we are just visiting each of the cell exactly one time, and if it is an n square size matrix, then the time complexity is also going to be n square, because we are processing each node exactly one time, and the space complexity is already n square due to the visited array that I have already taken, and also due to the queue. So that is why time and space complexity are both n square. I hope it is clear. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, we are given the board, and I will be finding the dimension. I will be taking max value as n square, and we will take the queue, push the first value, which is 1. Then I will be taking a visited array. This is a single dimensional array ranging from 0 to n square. So all of these values will be marked as false, right? You can also go with the 2-dimensional matrix, which is n by n size. Anything is fine. The visited at 1 will be true because 1 is the starting point. And now I will be taking the levels, and I will start the BFS, the level order traversal. So let me show you. It is a typical BFS code. So in this case, I will be doing the BFS until the queue becomes empty. Find out the size of the queue. Okay, and whatever is the size, you need to process those many nodes. Whatever is the size, take out the front of the queue, and then you check if the removed item is actually the destination, which is the max value n square. If it is, then return the number of hops as the shortest path. If it is not equal, then I will be calculating what is the next hop. So if I am at index current, then from current plus 1 to current plus 6 can be the next hop, but maybe the destination is before current plus 6. So in that case, I have to take minimum of current plus 6 comma maximum. Okay. So maximum is your destination node. Now, whenever you calculate any next index, I will be assigning it to destination for easier readability. I will be calculating the row and column. You know that if the row number is odd, then I have to take the mirror of the column index, as I have already explained in the flattening process, and the row number here, it is the top row that I have calculated. So the top row needs to be converted to the actual row. Top row is counting from top down, but in actual reality, in the input, it should be counted in the bottom up order, because our movement is bottom up, isn't it? So that is why the row has to be n minus 1 minus row. This row is the top row. So I'm not taking two variables. It is just taken in the same variable update. Now when the board at row column is not equals to minus 1, this means you have either a ladder starting at that cell, or you have a snake starting at that cell, right? So in either of the case, you take one time hop, one time free hop. If you want to take the ladder, you go up. If you want to take the snake, you come down. Whatever is the case, the number will be already mentioned in the board. So you take one time hop. Okay. So wherever you reach, whichever cell you reach, you have to check if it is already visited. If it is not visited, then mark it visited and push it into the queue. Otherwise, if it is visited, then skip that. So this will run in the level order traversal, and you will be incrementing the level as soon as one time you have processed all the nodes at the same level, right? And finally, if you could not find the destination node, then you will be returning -1 when the BFS ends. So this is the entire process, and I hope it is clear. If you still have any doubt, then feel free to comment below, and I'll try to help you as soon as possible. See you guys in the next video. Thank you.